Hi, this is Derek Daly, and this is my S5 assignment video. So I'll start by providing the problem statement, which is to recreate a gumball machine that vends out a gumball at the 75-cent mark. It only takes quarters, one could only be put in at a time. It has to be one hot uh, encoded, and it has to be able to manage held inputs. So, as you can see right in front of us, this is our completed circuit. How do we get here? Well, I'll show you. First, we start with our state diagram. We know that there's three sort of steps along the way. The 0 cent mark, 25-cent mark, 50-cent mark, and then since it's a mealy machine, which I failed to mention previously, it is going to be a mealy machine. It goes from that 50-cent mark. There is no state for that 75-cent because that is our special state. That's why I have the star when it goes from 50 back to 0 cents. So we have our one input, which is the quarter, and since this has to manage held inputs, we make it so where that if one is being held on the A state, it'll stay there. So it has to be released, as you can see by the zeros, um, going from the A states to the next state. Um, and it's also a one-hot design, which means that there's a flip-flop. Um, only one flip-flop outputting high at any given time. So, as you can see, the code is pretty long for that because we're going to have a total of 6 flip-flops for each state. So now that we know all this information, we're able to derive our present and next state table. And also, as you can see, I did the require flip-flop inputs, which I know wasn't required, but I still did it. And it also was an accident, but sort of helps prove my equations, which are down here. Oops, let me get rid of that. Yep. So from that table, we're able to derive our equations, and from there, we're able to derive our circuits. And yeah, so like I said, this is a one hot encoded circuit. As previously stated, only one flip-flop could be high at a time. This is pretty handy because it allows us to manage, our states. Honestly, personally, I think it's easier to manage the states like this. It's just very clear to see where we're at, especially with the, being able to hold or manage the held inputs. Um, I guess it could complicate things if you don't like everything expanded out, if you like the more abstracted versions. Um, but yeah, and managing held inputs is very important because obviously we don't do things in like a fraction of a second, if like we're clicking on a mouse or pushing a button in a vending machine, we do those things when you put in the input, you push the buttons for a few, for a period of time. It's not instant. So managing those held inputs allows, instead for like a million inputs in a second, it allows just for that one input to be, that one input that you wanted to input to go through properly. So yeah, here it is. Now let me actually demonstrate it. So I almost forgot to do that. So here we go. Put in one, and I did reset it right before this. All right, so one is being held. Look at that. All right, gonna let go, and it should go to the next one. There we go. All right, one's gonna be held. There we go. All right. And so we should get a gumball from Q4 to Q5. Let's see it. There it is. Beautiful. Alright, let go, and it should cycle back through. Let's see. There it is. Alright. Demonstrated and explained the circuit. I hope you have a nice day. Thank you.